All right, we're going to do vertex form today. Now, let's back up for a second, though. Remember, when we did equations of lines back in the fall, we had different forms. For example, y equals mx plus b. That was called slope-intercept form. We had y minus y sub 1 equals m times x minus x sub 1. That was called point slope form. And then we had ax plus by equals c. We didn't use that one that much, even though it was called standard form. My point is that there's different forms. So like quadratic equations, what we've been working with recently is standard form, which looks like this: y equals ax squared plus bx plus c. But remember, back when we were doing completing the square, there's also vertex form, which looks like this: y equals, so there's different forms of these equations. And they both have their pros and cons. So a times the quantity x minus h squared plus k, where h comma k is the vertex. If a is positive, it opens up. If a is negative, opens down. So that number in front of the parentheses, just like in standard form, determines if it opens up or down. Okay. Now, when we were working with standard form, we were able to quickly determine what the y-intercept was. We were also quickly able to determine if it opened up or down. Vertex form is different. Vertex form is called vertex form because we can quickly see the vertex. See, remember when we did this when we were completing the square? What's going to make this come out to 0? X is 1 would make it come out to 0. And that would be negative 4. Okay? Because whatever makes this come out to 0 is the x, and this number hanging off the back is the y. The axis of symmetry is always going to match the x value of the vertex, and this is going to open up because it's invisible positive 1 in the front. So this top row of stuff when you're in vertex form, easy peasy. Now, this negative 4 hanging off the back is not the y-intercept because this is not in slope-intercept form. All right? Sorry, this is not in standard form. You see, this negative 4 was the y value of the vertex. So to find the y-intercept, we actually have to calculate it. But we know that every y-intercept has an x value of 0. So I'm going to replace the x with 0. Now you're just going to follow PEMDAS. 0 minus 1 is negative 1. Negative 1 squared is 2. God, I'm having a brain lapse today. Negative 1 squared, of course, is just 1. Man, I'm getting all distracted because things aren't working right here. My pen's not working. So you get a y-intercept of negative 3. So all you're doing is plugging in 0 for x and evaluating. Now to find the zeros, remember it's called the zeros because y is 0. So I'm going to rewrite the equation. But we now have a different solving process. We've done this before. We didn't emphasize it. You see, we want to get this set of parentheses by itself. So we're going to move the 4 over by adding it to both sides. And now to get rid of the square, we're going to take the square root of both sides. Now I'm going to switch sides here. Remember, the square root cancels out this square, but you get the absolute value of x minus 1. Square root of 4 is 2. So now you do x minus 1 equals 2. X minus 1 equals negative 2. So if I move that 1 over, I get 1, 0, 3. If I move this 1 over, I get another 1 of negative 1. And now we have all our information. I had my vertex was 1, negative 4. That was down here. My y-intercept was that. My zeros that I just found was negative 1 and 3. Remember, there's an axis of symmetry going straight down through this thing. Okay. And let's balance this thing out. Remember, there's a mirror image to this point right there. And there you go. Okay, I'm going to skip this one for now. I'm probably just going to do, well, I'm not going to do all of these, but let's go ahead and do three and four. So the vertex again is negative 1 comma 8, because that's going to make this come out to 0. And that's the y value. Axis of symmetry is x equals negative 1. This is going to open down because of that negative 2. The y-intercept, remember, we want to replace the x with 0. 0 plus 1 is 1. 1 squared is still 1. So we have a negative 2 plus 8, which is 6. So my y-intercept is 0 comma 6. My zeros, I'm going to replace the f of x with just 0. And now we want to get this set of parentheses by itself. So we got to move this 8 over first. It would be positive on that side. We want to get rid of this negative 2 as well. So we divide both sides by negative 2. Sorry, this would be negative 8 on that side, right? Because I have to subtract it. So negative over negative is positive. Okay. So we got to take the square root of both sides. I'm going to switch sides again. Square root of this becomes absolute value of x plus 1 equals 2. So now I got two equations. X plus 1 equals 2. X plus 1 equals negative 2. I get x equals 1. I get x equals negative 3. So there are my zeros. My y-intercept, 1, 2, 3, 4, 5, 6, is right there. My vertex, remember, was negative 1 comma 8. That's going to be right there. There is my axis of symmetry. I would have a mirror image of this point right there. There you go. All right, same thing on this one. My vertex is 4, negative 8. Axis of symmetry is x equals 4. This is going to open up because that 1/2 is positive. Y equals 1/2 x minus, whoops, I'm finding the y-intercept. That means x is 0. 0 minus 4 is negative 4. Negative 4 squared is 16. Half of 16 is 8. And 8 minus 8 is 0. I'm going to find the zeros, change the f of x to 1/2. I want to get this set of parentheses by itself, so I'm going to move that -8 over by adding. Now remember, to get rid of this 1/2, we multiply by the reciprocal. That cancels the 1/2 out. So I get 16 equals x minus 4 quantity squared. Now when I take the square root, again, I'm going to switch sides again. I get x minus 4, but the absolute value of that, square root of 16 is 4. So we have x minus 4 equals 4. X minus 4 equals -4. If I add 4 to that, I'm going to get 8. If I add 4 to both sides there, I'm going to get 0. So there's my 0. There's my 8. Remember, my vertex was 4, -8, which is right there. So I'm actually graphing this one with just 3 critical points. That's okay. That happens sometimes. Okay. I'm going to go back and do the one that I skipped, just so you get a little flavor for that, number 1. And then we'll call it there. So you can think of this equation as being in both vertex form or in standard form. Okay. See, because it's just x squared, if it was written like this, now you see it as vertex form, right? But I want you to realize I didn't change anything. I just kind of changed how this looks. And if you see it like that, because x plus 0 is just x squared. You know, that vertex clearly would be 0, 4. So you see, when you have that vertex x value, 0 ends up being a little bit different. Okay. But you can also think about it as standard form too, because it's in standard form as well. And when it's in standard form, that thing hanging off the back is the y-intercept. You see, these happen to match. That's just, that happens sometimes. The y-intercept, if you have to calculate it out, remember, y-intercept, x is 0, so I replace it with 0, but 0 squared is 0, -0 is still 0, y equals 4, you see? We didn't have to do that though, I just wrote it down because it's standard form as well. Now when I find the zeros, notice how there are no parentheses and there's no b term. I can just use the square root method, move the x squared over by adding that to both sides, take the square root, absolute value of x equals 2, so that means x equals 2 and x equals -2. So sometimes you're going to get stuff that is in both vertex form and in standard form. Can make life a little bit easier. Okay. Hope that helps. Obviously, we will have covered this in class, but see me if you got questions.